Hello, hi, Assalamualaikum to the all panel. My name is Muhammad Syed bin Abdul Aziz, and today I will be presenting my thesis, which is application of bamboo facade system to achieve optimize the lighting performance. I will start by explaining about daylight. Daylighting has been found in study able to minimize the lighting energy usage, which is artificial lighting, while providing a visual comfort and a healthy environment for the resident. An audit was conducted by Pusat Tenaga Malaysia that light consumed 12% of the energy. So the lighting is more efficient in providing light and makes the office workers more productive. Moreover, by applying a daylighting strategies alone can result in minimum 10% energy saving. So based on that, I come up with a design strategy, which is the first one, facade treatment, and the second one is a material, which is bamboo. Before I further explain why I choose bamboo as a suitable material, I will explain about the issue. So as you can see from the graph on the upper left side, from this graph is that starting 1960, the amount of CO2 emission have drastically increased until present, and it will keep on increasing if there is no action taken. And this graph shows that manufacturing and construction is the third highest greenhouse gas emission this manufacturing construction sector for the greenhouse emission in Malaysia 2016. So based on this CO2 equivalent feeding component, it is by selection of sustainable building material can be a solution to reduce the carbon emission. So come with the question, why and how is bamboo considered sustainable? Well, bamboo is a grassy plant, which means the the growth rate are incredibly fast, which only 3 to 5 years the bamboo will be fully mature and ready to be used. Bamboo also have an ability to regenerate itself, so when bamboo mature littles are harvested, young shoots are sprouting up to prepare for the new cycle. So wood also is a natural material, so I'm comparing wood and bamboo. Well, for the wood or timber, it is harvested every 10 to 50 years depends on the species, whereas bamboo harvests every 3 to 5 years. Another good thing about bamboo is that it is a grass that can sequester 7 times more carbon dioxide than normal tree, produce 25 more oxygen than typical pine, and 1 hectare of bamboo absorb about 7 tons of carbon per year. So bamboo has a good mechanical strength, which is it has a as tensile strength as a steel, but less compressive strength as concrete, and a high bending strength as well. So for the growth phase, is like I explained earlier, which is renowned for its O2 absorbing and O2 producing capacity. So after it harvested, the bamboo is cured to prolong the lifespan, and will be then after that will be ready to be used for the building material. And for the end life phase, if maintained well, bamboo product may be reused in similar application. But if that is not possible, it may be used can be used as an input material for the shipboard industry. So then I come up with my aim, which is to design a bamboo facade that helps in optimizing daylight performance and reducing carbon footprint for building in Malaysia. So the objective is to achieve optimized daylight performance by using bamboo facade system as sun shading device in tropical climate, and then to explore the application of bamboo as a sustainable building material in a building, and to explore the kinetic mechanism in facade system. So our site is located at Johor Bahru, beside the Astaka Tower, Astaka Condominium, which is the tallest building in Johor. For the building typology, the proposed building program is actually mixed-use development, which is there is an office tower and a commercial block. And applying the using fractal principle. So what is a fractal? Fractal is actually a natural phenomenon or mathematical set that exhibit a repeated pattern that display at every scale. So so it may change in size or rotation, but the shape will remain the same. So I am applying the fractal principle in my rules, which is using the cubic shape. It can change in size or rotation, but it will remain the cubic shape. And so using the principle of locking, rotation, and repetition. This is just a pattern exploration using cubic fractal. So for the simple cubic, it can transform or changes into various different form. So for the facade treatment, The closest sun position to the equator is actually March and September, and the farthest sun position is June and December, which means the horizontal sun elevation or azimuth varies or changes during March, June, and December. This one is based on the guideline on operation safety. Based on the guideline, recommended and optimal lux level for the office is actually 300 to 500. So our design brief actually required us to tackle west and east sun. However, as you can see from the shadow study, the Astaka Tower are actually shaded the site during morning. So which means I will be focusing and tackling the west sun. This, so this one is the shadow study for March, June, and December during 4 p.m. At 4 p.m. As you can see, the azimuth angle actually changes from March, June, and December. Based on the analysis done, I propose the rotating facade. So the facade will rotate according to the azimuth angle, which means during March and September, the facade will rotate 45 degrees to the north. During June, it will rotate 45 degrees to the south, and during December, it will remain at 0 degree. So to study the efficiency of rotating facade, the first simulation was done without any facade treatment to do the comparison study, and based on the result, the lax level are excessive. The second simulation is done on March, which is the facade are rotated 45 degrees to the north, and based on the result, the amount of excessive lux was reduced. However, the lux was still quite high at the area near the facade. So the third simulation was done on June. The facade rotated 45 degrees to the south, and it got the same result, which is the excessive lux was reduced, and but the lux level are quite high at the area near the facade. During the fourth simulation is during December, which is the facade remains 0 degree, and they had got the same result. The second facade system is a foldable louvers to tackle the sun angle that changes throughout the day. Foldable facade function to block the sun and provide optimized daylight performance. So this is the previous simulation result, and to do comparison of facade with foldable louvers. The sixth simulation is done during March at 3 different hours, 9 a.m., 12 p.m. and 4 p.m. with different opening. Based on the result, SSC level near the window is reduced. Seventh simulation is done with the same method but during June and have the same result, which is the result. The excessive flux level near the window is reduced. So for the eighth simulation, is also done with the same method but during December and have the same result. And with that, I can conclude that the rotating facade combined with the foldable louvers provide an optimum daylight performance. This is a simulation of the whole office floor on March, and it got the result. Then the result is optimum. The same result is achieved with June and December. This is the facade editor that uses the mechanism of battery system to rotate the facade. The strategy for the application of bamboo, the strategy is to replace 60 to 65% of standard building material. For commercial block, the structure and the wall will be using bamboo, and for the office block, the internal wall and the facade will be bamboo. So this one is just the exploded of the bamboo facade, the rotating facade. Sorry, this one is the exploded for the rotating facade. This one is the bamboo detail for the bamboo structure and for the jointing. So for the form making, the form are started by offset for 6.14 meter for root and bomber circulation, and then the commercial is placed on the west side, facing the main road to become the magnet for the visitor, and the tower are placed on the east side. The middle are empty out for for plaza for human activity and interaction. And then the commercial block are rotated 45 degrees to avoid the direct evident sunlight. And applying the fractal rules, which is the cubic structure, are all modified by the same scaling factor. And then applying the facade into the tower block, and I put a bamboo structure roof on the plaza, which is to create and to provide shade from rain and sun, and also to become symbolized as bamboo structure as bamboo sculpture. So for the subplan, there will be one ingress and two egress. So the first egress is here, another egress is over here. So the program for the ground floor will be mainly F&B, proposing two drop-off, one for the commercial area, another one for the office, and this area will be for services. Level 1 and 2 will be mainly for retails. Level 3 will be semi-private as there is a multi-purpose hall and seminar rooms that can be rented out. Starting level 4 until 15 will be completely private and mainly office. And for level 14 and 15 will be for penthouse. This is one, it's just a basement. It's my elevation section. And this is the exterior perspective. So this is the outcome, the perspective of rotating facade. This will be the perspective of my plaza, the office, food court, and the facilities area. For the conclusion, as the visual comfort in the office space does affect the productivity, and by employing the light in the building is able to save energy, thus kinetic bamboo facade system was proposed to tackle this. Based on the study, the rotating facade and foldable louvers successfully provide optimum daylight performance in the office space. And then for the application of bamboo as a material was proposed, as bamboo is known as a low carbon emission material. Nevertheless, a proper calculation are needed to prove that the proposed buildings carbon emission are reduced. Thank you very much, and this is a video, walkthrough video thing. That's all from me. Thank you.